Let us recap in this video how aluminum chloride reacts with water. This is nothing new, so this is just a recap. You learned this in JC1 last year, in chemical bonding, at the very last part. The reaction of aluminum chloride and water can be understood as consisting of two stages. The first stage is dissolution or dissolving, where aluminum chloride simply dissolves in water, a full forward arrow, to give us the cation and anions. Now you may be tempted to write it as the cation this way, but let me remind you, we do not accept this in the A levels, because in A level chemistry we expect you to write the more accurate version, AlH2O6 3+. You see, in aqueous medium, Al3+ does not exist alone on its own. The water molecules will form dative bonds to the Al3+. You see, in this structure over here, what happens is that the oxygen of the water uses lone pair of electrons. Its lone pair of electrons to datively bond to the empty orbital of Al3+. And 6 water molecules do the same thing to dative bond to the Al3+, empty orbitals, and we get this structure AlH2O6 3+ with the charged oxide. So what happens next involves this particular cation, Al3+, with 6 water molecules datively bonded to it. So this particular AlH2O6 3+ ion, I have already highlighted in yellow, it will undergo hydrolysis. What is the meaning of hydrolysis? Lysis means bond breaking. Hydro means water. So what we are saying is that a bond in water actually breaks, the OH bond. Why does this occur? It simply occurs because Al3+ has a very high charge density. Let's recap what is charge density. Charge density of an ion is equal to the charge of the ion divided by the radius of the ion. With a +3 charge, the charge is very high, and Al3+ is small. Therefore, Al3+ has a very high charge density, and what it does is that it attracts the electron cloud of the water and the electron cloud of the OH bond of the water to its cells. So you can imagine the electron cloud of the OH bond is being put towards Al3+. This process will polarize the water molecule, the OH bond of the water, and weakens the OH bond of this water, and therefore causing it to break. And when this OH bond breaks, this hydrogen comes out as a H+ ion, giving rise to the pH that is acidic, which in fact is 3. So this is the H+ that comes out. The pH is 3. Notice that the arrow is an equilibrium arrow, meaning that the reaction doesn't go to completion. Therefore, the pH is not that high. It's only pH 3. We cannot get all the OH bonds of this water molecule to break. Remember, water is very stable because the OH bond of water is strong. It's not that easy to break the OH bond of water. So, in some of this AlH2O6 3+ ions, this OH bond breaks to release H+, to give us a pH of 3. We say that this is hydrolysis process, and it is a partial hydrolysis, so please take note of the equilibrium arrow. Notice the charge must be balanced. So on the left side I have 3+, on the right side I should have +2 and +1. So that on the right hand side the charge is still +3, which is the same as the left hand side. So this is how aluminum chloride reacts with water, undergoing partial hydrolysis in the second stage to give us H+, and that accounts for its pH of 3 in water.